Okay, welcome to another session in this series. In this session, we start with question number 38. Previously, we ended on question number 37. Okay, so let's start with question number 38. It says, if 23 base x, 23 base x plus 101 base x is equal to 130 base x, find the value of x. So we just need to convert everything to base 10. Okay, cool. So how do we do that? Sorry, we number our digits 0, 1, 2, 0, 1, 2. Okay, so let's start with the first one, which is 23 base x. What do you have? You have 2 times x power 1 plus 3 times x power 0. That will give us what? 2x plus 3. Okay, cool. Let's move on to the second one, which is 101 base x. That will give us 1 times x squared plus 0 times x power 1 plus 1 times x power 0. That will give us what? X squared plus 1. Okay, and then the last one is what? 130 base x. That will give us 1 times x power 2 plus 3 times x power 1 plus 0 times x power 0. That will give us what? X squared plus 3x. Okay, so now we just need to put them into the equation and then we get our answer. So that is 2x plus 3 plus x squared plus 1 is equal to x squared plus 3x. Okay, so let's try to solve the equation. X squared will cancel 3x, then we are left with 2x plus 4 is equal to 3x. Finally, x would give us 4. Okay, so our answer is 4. Cool. Let's move on to question number 39. It says, find the product of 1101 base 2 and 111 base 2. So we just multiply, right? 1101 times 111 base 2. Okay, so we just multiply. You will do the same thing for the next one. 1011. Finally, the last one we have 1011. Okay, so now we add. Here we have 1, here we have 1, and then 1 plus 1 here. 1 plus 1 here will give us what? 2. 2 in base 2 is what? 10. Okay, and sorry, 1 0. So we write 0 here and then we move the 1 right here. Okay, so we have 0, then the 1 will come here. Okay, so now this 1 plus 1 plus 1 will give us what? 3. 3 in base 2 is what? 1 1. Okay, 1 1. So the 1 will be written here and the 1 will transfer to this side. Okay, so we have 1 here and then the 1 comes here. Okay, so here too we do the same thing. 1 1 1 is what? 1 1 base 2, right? So this 1 will be written here and then the 1 will be transferred to this side. Okay, so we have 1. So now we transfer the 1 from here to here. So what are we left with? You have 1 plus 1 in base 2 is what? 10 is 2. 2 in base 2 is what? 1 0. So we write 1 0 0 1. So that is our answer, base 2. We have that 1011 1011 base 2, which is D. Okay, cool. Let's move on to question number 40. Okay, it says, in what number base was addition 1 plus nn equals 100, where n is greater than 0 done? So we want to find the base in which this addition was done in order to get 100. Okay, so what that means is we are going to add n plus 1, and that will give us what? 100. Okay, cool. So now let's take it one by one. If we add n1, let's normally in base 10, when we add n plus 1, what will you get? When you do that, you get what? n plus 1, right? So in what base it says that when we do this n plus 1, we would get something that is what? 0. But keep in mind that they said n is greater than what? 0. So we cannot just say that n is equal to -1, so that when you add -1 plus 1, you get this 0 right here. Okay, that's not possible because it said n is greater than what? 0. Okay, so there's no way this n is equal to -1. Okay, cool. So what that means is that this is a number such that when you add that number to 1, it will equal to this. The base will be equal to what? The base in which you're adding will be equal to that sum. Let me give you an example. So for example, if you have 22 plus 1, and we said that here the answer is 1, 0, something, something, something. But we know that normally 2 plus 1 is what? 3. Okay? 3. Okay? But what that we have 0 here? That means that we are adding in a certain base that will make sure that this will become what? 0. And the only base that will be is what? That sum, 3. Because 3 in base 3 is what? 1, 0. And then that 0 will be written over here as the remainder. Okay? And this will be the one here will be the dividend. Okay, so the only way we can get this sum to be 0 is when we are adding in a base that is equal to that sum. Okay, so 2 plus 1 is 3, and we've written here 0. That means the base in which you're adding is what? Either 3. Okay, that's 3. Okay, cool. So that's just an example. So similarly over here, whatever we add, if you're going to get 0, that means we are adding in that base. Okay, the base we add in is the same as the sum. Okay, cool. So our base is what? N plus 1 in this case. To further confirm that our base is actually n plus 1, let's continue, because when we do n plus 1, we see our sum is what? N plus 1, right? Okay, so when we are saying that the base is n plus 1, that means when we divide n plus 1, we should get our dividend to be 1 with a remainder of what? 0. Do you get it? Okay, so that means this 0 comes here, and then the dividend goes and then add the other 1. Okay, cool. And then that same one here will continue to add n, and then you know that 1 plus n is what we're adding. If it is in that base, the base is n plus 1, that means you still have what? 1 remainder 0. Okay, so that is how we have 100 over here. So our base is what? N plus 1. That is our base, which is C. Okay, let's move on to question number 41. It says 243 plus 452, so 243 base n plus 452 base n is equal to 1135 base n. Okay, so we find the base in the value of n. So what we do is what? We just we change to base 10. Okay, cool. So let's do that. For the first, we have 0, 1, 2, 0, 1, 2, 0, 1, 2, 3, as usual. Okay, so let's do that. So we're going to have 2 times n squared plus 4 times n power 1 plus 3 times n power 0. That should give us what? 2n squared plus 4n plus 3. Okay, cool. Now let's do the second one, which is 4 times n power 2 plus 5 times n power 1 plus 2 times n power 0. That will give us what? 4n squared plus 5n plus 2. Okay, cool. Now let's do the last one, which is the one at the other side of the equation. We have 1 times n power 3 plus 1 times n squared plus 3 times n power 1 plus 5 times n power 0. What do we get? N cubed plus n squared plus 3n plus 5. So now we do what? We add everything and then we equate, okay? So we're going to have 2n squared plus 4n squared is what? 6n squared. 6n squared plus what else? 4n plus 5n is what? 9n. 9n. Then 3 plus 2 is what? 5. To be equal to this one, okay? N cubed plus n squared plus 3n plus 5. Okay, when we simplify this, we find that you get n cubed minus 5n squared minus 6n equals 0. We can factor n out, right? So if you factor n out, you have n squared minus 5n minus 6, and this is a quadratic, okay? Let's forget equals 0. This is a quadratic. So this quadratic, what we need to do is what? Multiply the coefficient of n squared by the constant, which is -6, and find two numbers such that what? When you multiply them, you get -6, and when you add them, you get the coefficient of what? -5. Can you think of those numbers? Those numbers are -6 and 1. Because when you multiply -6 and 1, you get -6. When you add them, you get what? -5. Okay? So those numbers are -6 and -1. So by solving the quadratic, you're going to have our solution to be n multiplying n minus 6 n plus 1. Because our factors are what? -6 and +5. Okay? Now equals 0. Okay? Equals 0. So now this is our simplified quadratic. So now we just need to equate each of them to 0. So that means our values are n equals what? 6, n equals -5, and n equals what? 0. Okay? Cool. So now we know that our base can only be what? Positive. Okay? So now that means our answer is what? N equals 6. So our answer is n equals 6. Cool. Thank you so much for watching this session. In the next session, move on to question number 42. Thank you so much. See you again next time. Bye.